Hello folks, and welcome to this lesson on organic reduction reactions. By the end of this lesson, you should be able to write the reduction reactions of carboxylic acids, aldehydes, and ketones, and write the reduction reactions of alkenes and alkynes. So you can oxidize organic compounds, you can also reduce organic compounds. As a reminder, reduction of organic compounds means that the organic compound will be gaining electrons or hydrogen, or they will be losing oxygen. There are different reducing agents that you can use. Some examples are going to be lithium aluminum hydride, which you then react in ethoxyethane, and then you put the whole situation into an acidified solution. This is quite a strong reducing agent and will be able to take carboxylic acids all the way to alcohols. It is going to be two steps, so you're basically going from the acid to the aldehyde and then from the aldehyde to the primary alcohol. Another one that you can use is NaBH4 with methanol, and this one will be able to take aldehydes and ketones to alcohols. The important bit of each of these reducing agents is the fact that you have these hydride ions. So these are all H- ions, and this is what is going to cause the reduction to happen. And so because of this, when you're using an unspecified reducing agent, it is written as an H in square brackets. I'm going to be honest, I'm not as particular about my reducing agents as I am about my oxidizing agents. So no matter what course I'm teaching you, if you want to use your just the generic reducing agent, that's perfectly fine with me. So writing out what the reaction is going to look like, it's going to look similar to an oxidation reaction for any one of these. Draw the reactants, draw the products, use that H in the brackets, and then that's about it. I am simplifying the reduction of your carboxylic acids, aldehydes, and ketones because they're a lot simpler and they are pretty much the reverse of the oxidation of your alcohols, aldehydes, and ketones as well. Now, this lesson isn't over yet because your oxygen-containing compounds aren't the only things that you can reduce. You can also reduce alkenes and alkynes. Basically, making these unsaturated hydrocarbons saturated is a reduction because you are adding hydrogen. You're breaking the double or triple bond, and if you add hydrogen to it, that's basically a reduction. Now, this is the one reaction where balancing is actually a little bit important, because when you're going from an alkene to an alkane, however many double bonds you have, you take that many hydrogens, and then you're just basically adding an H2 to every double bond that you're breaking. On the other hand, when you have an alkyne, it's a triple bond. And so if you're going to take that alkyne and make it all the way into an alkane, you need to make sure that you have enough hydrogens. And so for every one triple bond, if you want to make it into an alkane, you're going to need 2 moles worth of hydrogen. You need an excess of hydrogen. If you don't have enough hydrogen, you are not going to go from a triple bond to a single bond. You're going to go from an alkyne to an alkene instead. These reduction reactions also use a catalyst, and that catalyst is typically going to be a metal. Nickel and platinum are sort of the usual suspects in this one. So as an example, if we were to write the reaction for the reduction of hex-1-ene, it may look like this. You start with your hexene, you end up with your hexane. You need to make sure you're adding in the hydrogens, make sure you have your catalyst, and there you go. Something else that I want you to keep in mind is that this particular reaction, while it definitely is a reduction because you are adding hydrogens to these carbons, there is another name for this type of reaction. I did mention that your double bonds and triple bonds are actually a lot more reactive, and so hydrogens are not the only thing that you can break those double bonds or triple bonds and then add things to. There are other types of compounds that you can add to these double bonds or triple bonds. And so that whole class of reaction can also be referred to as an addition reaction. So this is one of many other kinds of addition reactions, on top of also being a reduction reaction. I will talk about those other addition reactions in a different lesson. And so that's it for this lesson. I'll see you next time.